Hello everyone and welcome back to Data Science and AI lecture series from PostNetwork Academy. I am Bindeshwar and today we are going to break down a fundamental concept in data analytics, understanding and calculating quartile deviation. And for more resources, you can reach website www.postnetwork.co, YouTube channel, Post Network Academy Facebook page and LinkedIn page. So quartiles divide a data set into four equal parts, giving us insight into the spread and the central tendency of the data. The first and third quartiles, Q1 and Q3, represent the 25th and 75th percentiles respectively. By you can say that, but why is quartile deviation so important? Quartile deviation, also known as semi-interquartile range, tells us how concentrated the middle half of our data is. Unlike standard deviation, which can be heavily affected by outliers, quartile deviation is more resistant to extreme values. I will show you. This makes it especially useful in data science where data sets can be skewed or have outliers. So let's start by calculating Q1. So here first quartile Q1 is the value at 25th percentile. So position of Q1 is n plus 1 upon 4 and if you count, so number of observations are 10. So Q1 position is 2.75. So the 2.75 position is between second and third values. So we interpolate. So Q1 is equal to 4 and the interpolation part. So finally we will get 5.50. Let us calculate third quartile. So third quartile position you will get by multiplying 3 into n plus 1 upon 4. And again number of observations are 10. So Q3 position is 8.25. So 8.25 position is between 8 and 9th value. So we interpolate. So Q3 we will get 16.50. And the interquartile range is difference between Q3 and Q1. So IQR is 11. And the quartile deviation is half of the IQR. So you will divide and you will get. Now let us visualize. So here this is a number line and all data points I have plotted or written. So here Q1 is 5.5 and you can see the position. And here Q2, that means median, that is 11. And Q3 is 16.5. Now interquartile range, you will subtract Q1 from Q3 and that is 11. And the quartile deviation, that means 5.5. So the quartile deviation of the data set is 5.5, which reflects the average spread of the middle 50% of values around the median. Now, as I explained to you that extreme values will not affect. So, values after 16.5, if you increase like 20 to 2000, so see that interquartile range would be the same and quartile deviation would be the same. So extreme values will not affect after 16.5. If you change like 18, if you change 1800 and 22,000, still quartile deviation and interquartile range would be 11 and 5.5. That's why it is unaffected from outliers or extreme values. Or you can say that from skewed data. So hope you understood. this concept. If you like video, subscribe the channel, follow us on Facebook page and LinkedIn page. See you in the next video.